Now we're going to take a look at RGB LEDs. And the main difference between a regular LED or an RGB is, just like the name implies, in an RGB LED you have an individual red, green, and blue LED in one package. And they typically have 4 wires coming out of them. Now what you need to know about this is there are differences between common anode RGB LEDs and common cathode. And I can't tell you how many times I've had a student or a friend or somebody, even myself, mix it up and not know whether it was common anode or common cathode. And one simple way of checking is, again, with our CR2032 coin cell battery, we can just make a few connections and see. I happen to know that these are common anodes, so looking at the data sheet, I know that the long lead is the positive and all the additional leads are the red, green, and blue LEDs. So let's take a look at how we could even test that. If I were to put the coin cell positive on the long lead here, negative on this one right here, I can see that's the red LED. If I flip it around, and what I'll have to do is just move this one out of the way a bit, and I flip it around and put the positive on that long and the negative right there, there's my green. And if I bend the green out of the way, put my positive here, negative there, there's my blue. And you can mix these. Don't forget, if I put my positive here, I can mix my green and my blue. Should get a little bit of a turquoise color. There you go. And I could even move the red around there and get, well, I'm not able to get that. Red is overpowering. But you can mix them. And that's what we're going to take a look at with the Arduino code. So first, let's wire this up. So if you saw earlier, I had the long lead is the positive. I'm going to just spread these out a little bit. I'm going to use up rows 1 through 4 and put them all into this column F right here. It's a little tricky to get them all in there, and I know that this one in row 3 is the positive. So in this case, I'm actually going to take the positive and connect it with a yellow wire, and I'll show you why I do that. I'll connect that over to the positive 5 volts of the Arduino. Now, the reason I use the yellow wire, and by the way, here's a couple of extra RGB LEDs, and they have the same 4 wires, but we're using the square one. Why? Because it's nice and bright for the camera, and I actually just like these rectangular LEDs. Now, here's why I use yellow for positive instead of red, because it's really nice to match up your wires to the leads on the LED. I happen to know that that first one was red because we tried it already. This one next to power was green, and the one next to that is blue. Now you'll notice something. I didn't do it yet, but I just wanted to show you. I can either jump these to another spot in the breadboard, or I can jump the gutter with my resistors. So I was going to use these wires and run some more, but it's just cleaner not to do that. So how about this? What if I just take my 220 ohm resistors, and I'm going to take 3 of them, and if I just take my LED and move it across the gutter over into column A, like that, I can use the resistors to jump all of the various LEDs in this package. There's one on the blue, here's one on the red, and here's one on the green. And because we are jumping the gutter now, I'm going to need one more to jump the power over. Or I could move the yellow wire over, but you know what, just for clarity, I'm going to use the yellow and jump the gutter. Make sure I get it into the right spot here. And I think I'm off by one with this bottom resistor. There we go. Okay, so now I have all my resistors in. Remember, I'm using 3 resistors because essentially I have 3 LEDs. It's just in one package. Now let's take a look at the code before I wire this up, because I'm not sure where we need to put these wires. And the Arduino website has great code for all different experiments with an RGB. I'm going to use a very simple one that's going to fade the colors, and I can show you where that is. I did a search for RGB LED, and I came up with this code right here, the cross-fading 3 LEDs. There's not a lot of information about it, which is pretty interesting. because you don't really need a tutorial because the code is so commented and easy to implement. You don't even need a tutorial to tell you step by step how to do this. So let's copy that and get it over into the Arduino IDE and take a look at the comments. Okay, paste it in there. I will hide the web page that I got it from. I will scroll up. So here it says the definition of the pins. Really easy. Red, pin 9. So let's take the red, put it into digital pin 9. Green, pin 10. That's easy enough. And blue into pin 11. And if I go through the rest of this code, I can see they store the values of the different integers here, red, val, green, blue. There's a weight in here and a loop counter. We have to define our pin modes, that they're all out. There's this interesting debug feature, and that looks like it's putting out a bunch of serial output. So I see a serial 9600 here. And essentially what this is doing is it's going through a loop, and it's probably easier to just upload the code and show it and then refer back to the actual sketch. Let's look for the port again. There it is, and I should be able to upload it. Let's take a look if it's uploading. There you go, it's blinking away. And there's the LED already doing something. That's a really slow fade between all of them. Now you can see it's going into a purple and a pink, more of a white and a green. It's awfully bright. I don't know if that's a little easier to see on camera. If I open up the serial monitor, I see nothing's going on. So back to the code. Let's look at where that debug is. Ah, there you go. Debug equals 0. And it says right here, if set to 1, it will write values back to the serial. So let's put that at 1. Let's re-upload the code. There it is, blinking away. There's the LED cycling. Now let's open up the serial monitor. And it's actually giving you all the RGB values that it's writing. So this has a little interesting bit of code that if you have debug equal to 1, it prints to the serial monitor. Otherwise, it doesn't. You can actually get rid of all that debugging code and serial monitor code. It's not going to affect the way this works. It's a fun experiment. RGB LEDs are great because you can have one indicator light. If you're building a very small project, you can have a very small RGB LED in there, and you could have it set to green for good, red, yellow. You could have it change all different colors. Very handy, very interesting, and a lot of fun.